words about how we build PostgreSQL-as-a-Service at scale, fully powered by open source tools and technologies. And when I say enterprise scale, I mean not only database size or number of transaction requests, but also the things which users may be concerned about, availability, backups, observability, and so on. So everything that makes database work uninterruptedly in private service. A few words about myself. I'm a chief database architect at Acronis with over 2 years of experience in databases, mostly focused on mission critical and high-level, large-scale database systems. Also, before we dive deeply into technical stuff, just briefly about the company, where we build our platform, I would say, so Acronis, as John said, is a cybersecurity company, which was this year recognized as a champion in categories cybersecurity leadership metrics. With other top vendors. More than 20,000 service providers trust our solution and protect more than 750,000 businesses. And a few more numbers. We deployed in 30 countries and have more than 50 centers. Each data center is separate databases also. Why do we talk about it? Generally, creating databases is not a simple thing. I suppose everyone who works with databases knows it. And commercial databases, of course, they provide solutions, but this is not very expensive. And you have some limitations with them. While we, on the other side, we wanted to have full control of the things that we use, the technology that we use, at the same time having all the things that, for example, from the PostgreSQL out of the box we don't have, like you just mentioned, availability, security, monitoring, backups is there. I'll talk about it later. What we're lacking in the out-of-the-box backup. Another important thing that is developer self-service. I call it here with that. With it, I mean that usually, because from my experience, you would be in a situation, if you're an expert in database, you would be in a situation when you have one expert and dozens of developers around who are using the database, and they expect some expertise from yourself, or at least they expect the database will work somehow magically, performing good. So with sharing as much as possible with developers, we allowing us ourselves to scale. That's why there was also one important thing is somehow to provide to give developers as much options as possible. So briefly, what we'll cover: what is enterprise grade, then how to achieve each of the points bullets that were mentioned before, and some summary. So first, enterprise grade is not just a buzzword, right? It's actually what business expect from the services, from their mission critical services. Each business thinks that their service is like the top one and most important, right? If you have a database, it should be silent to all interactions. It should continue to work and to provide the service. No database, no service. Customers are unhappy and no trust. So you need to provide resilience, business impact resilience, quality, and eventually trust. Because if customer trusts business, business trusts the service they provide. The service has somewhere there to be fixed. And how do we achieve it? Again, as I said, we have a database. On top of it, we build availability to make it available, backups, auditing, security, monitoring, scaling at the end, and And yeah, so let's start with technical things. First point, availability. One of the major pros in working with open source is you will have many solution list, variety of solutions for the same thing. Let's say availability. It can be achieved with different tools. One of them is Patroni. It's like the most well-known of PostgreSQL world, and we decided to use it. There are other solutions like scalable and others. So we stopped on Patroni. It is our cluster management and automatic our stuff tool. What else? Also it has built-in integration with console. We use console for Patroni data. Why this integration is important is because actually our clients use host names. They don't stick with IP addresses. That allows us to move databases around the data center, even cross data center if we have data center connectivity, transparently for the clients. So what client does, what application does, client and application, or database client and application. So application would reach console with a host name. It will be resolved to an IP address, even if Patroni, let's say on this diagram we have here the linear is not, even if for some reason or any end it happens. I would say every week we have some switches transparent for us for operations team. So if it changes, so application just will get a new address of the new. This is how we use it. Then the golden rule is you should have 3 nodes in a cluster so that you provide availability. We use this approach, and we decided to have one node as synchronous replica, one node as asynchronous replica. Just not overload the leader node with 2 sync replicas, and to still keep good response time. But at the same time, having sync replica, we guarantee that we will not lose any data. Again, meeting business requirements. I would say more, this is not on the slide, but some services, we eventually came to the conclusion that some services doesn't need that level of guarantee of safety with data. And they're fine with like losing some latest changes, some latest transactions, but they are huge, for example, like something like our data, let's say. They're fine with losing last few lines, right, of events, but they're big, few terabytes of data. For them, we agreed that we are fine, and we will have just 2 nodes, because redundancy, you understand, right? 3 nodes means more expenses on the hardware. We just use 2 nodes for them, and asynchronous application. So we set availability on top of consistency. This is a cup theory, but I will go into this theory. Yeah, I will, on the next slide, I will share more about how Patroni, how PostgreSQL actually works with our application in PostgreSQL works. Some more details, like kind of technical also. 2 nodes. When we say, oh, the node is synchronous node, we mean, like by default, it means that there is infinite. But what does it mean in fact? And there are 4 stages of PostgreSQL which guarantees that the data will be copied to the replica node. The first step is saving the data, and actually here the screenshot from our demo for the lag between leader node and the replica. I will tell much more about monitoring later, but here just about replication. So the first step is send lag. Send operation when the leader node sends the data to the replica node, and that's it. It is somewhere in the network buffer, let's say. the fastest one. The second step is when replica node drops the data on the disk, writes the data on the disk, and then replica confirms with the leader, it says to the leader, I'm fine, I'm done. Which is still, at that moment we still understand, right, that if our storage doesn't have battery and there will be outage, electricity outage, then we will again lose the data. So it's kind of synchronous but not synchronous. We still have a chance to lose the data. The third step is flushing the data on the disk. It is real flush operation in the minutes if you go with the SQL. At that moment, PostgreSQL guarantees that the data is on disk. Now we're safe. But there is also a fourth step. Now the replica node needs to replace this on a standby node, because before this step we'll complete the replica node. If the client will read the same data from the leader and from replica, it will get different results. So we think it's synchronous replication, but in fact the data will be different. So the fourth step is replaying these changes on the replica node. Now replica has the same data as the leader. If you will, if we will pay more attention to the scale of these charts, we would see that the first three steps are megabytes, less than 10 megabytes. The first is just network, it's 5 megabytes scale. So now there's 10 megabytes, and with Lilac, we can see 1 GB, almost 1 GB. So if we would, there is a possibility. PostgreSQL allows to configure each step, like what do you consider as a replication, as a synchronization. When the leader would say to the client, I'm done, I save the data, and it is on the replica node. But we see, right, that if we would say that we want to guarantee that even the read request will get the same data, the same response, it may take some time, a long period, which means clients will be affected. So we sacrificed this step, and we are saying to our applications, like guys, when you read from replica node, you may have outdated data for, usually it's nanoseconds, sometimes milliseconds, sometimes maybe seconds, but this is like exceptional case. Usually still it's not in seconds, but it is possible. So we're satisfied with this. That is what we call synchronous.
We're still talking about read-only replica, right? It's read-only replica.
Yeah, in PostgreSQL there is only read-only replicas.
I've heard some other solutions, but I never used them. Okay, what's the yellow read lines here? I'm not sure.
Just another step.
So we, as I said before, we have one reader, two replicas. Green is one replica, yellow is another.
Okay.
I just blurred it because
just
internal data.
And both of them are synchronous.
No. One is synchronous, one is asynchronous.
Yeah, and which one is which on this chart? Like, I'm looking on the chart, but I'm not seeing.
For that, I need to scroll up, but this screenshot. We have this information on that.
I probably don't need to dive too deep here. Okay, I see.
No, I'm saying we have this on this dashboard, we have this information. Just on this screenshot, as I said, it's not important.
Alright.
You will see just 1, 0. That's it. 1 will be 1, which means synchronous, 0 will be asynchronous. So, the next, we have backups. We have backups. Initially, we were using pg-based backup, which is obvious. It's just always comes with PostgreSQL. But at some point, we found that some databases are so active that they generate so much information, so much WoW files, that just while we are doing the backup, full backup, the WoW files are rotated, and then the backup is inconsistent. There are solutions that it is possible to store the base backup, to make a backup using base backup, saving in parallel the main backup file and the WoW files. But because of our legacy solutions, we weren't able to do it. So this is one thing. Actually, I'm now speaking about some internal stuff of Postgres, but no, probably I need to describe what is raw files and all that.
I know what raw files.
No? Okay, anyway, maybe in short, just so PostgreSQL to make sure that the data is safe. It writes the data not directly. It's also about performance, so it doesn't write data directly to data files, but it first writes to logs, which is this write ahead logs. And then if it needs or when it needs, then it applies these changes to the data files. There is a concept of checkpoint and so on. This is not in this presentation, I will not get into these technical details. So, also, another thing is that with using pg-based backup, we had to write our own solution how to copy this data to S3 and then to GCP, because we use GCP also as a long-term storage. Then, so to solve all this, we did research, internal research. Again, open source, we have many tools to make backups. We did research and we decided to choose pgBackRest. It's one of the top, most popular now solution. And we now see why in the company. So with pgBackRest, we have full incremental backups. Also, we keep raw files, we store raw files, which guarantees us RPO, so we will not lose, in case of any incident, we will not lose more than 30 minutes of data. It has built-in retention policies. So before we had Python scripts and so on, now we don't need it, just configure pgBackRest, all we need. Let's say built-in support for cloud storages and S3. Which again, we just removed what we had and we're using just what provides out of the box. And one of the best features is probably support for multi-threading. Now, for five-time recovery, you can still have with pgBackRest backup, but multi-threading is not what you have. So you always have just one thread that will do backup or recovery. Unless you're using directory mode for pg-based backup, but this is, I never seen that maybe someone using it. So with this, and this week we did research what will be the performance if we have three nodes, right? One node, let's say we need to reinitialize one node in a cluster. How it will work now? It will connect the leader node, copy the data from there, using pg-based backup, and that's it. Again, one thread. With pgBackRest, we can configure the replica node to recover from the cloud or from S3, not from the leader node. With that, we're creating a less load on the leader node first, and second, which was a surprise for us, we didn't expect it, but it is using multi-thread copying. It copies in multi-thread. And instead of
different tables or something more granular?
We didn't research it yet.
Okay.
Because we just found it this week.
Maybe just using first just the normal data, which is normal, but it will push it to the node with just one thread. It's totally possible.
No, it just copies, because the backup is already backup of files.
Okay.
So it copies all the data, and actually you have the data file. Then you have to apply.
What is the output format of this stuff? So, okay, it's backup stuff. What the format? What do you receive? Is it just normal PG restore format, or
not a PG restore? No.
So you have to run some kind of daemon which would restore the basic data.
There.
Okay, and during this time, this node would be offline, and we would of course.
So if you're recovering from backup, then you don't have no.
And you basically, after this, you start with the database, right? So it restores into the file, then you can start with the database on the restored storage, or we can insert.
Look, so it's not dump, it's a backup.
Okay.
With dump, which is logical data, right? You apply it to already working database.
Yes.
That's why it is working, it's available. You just maybe you are restoring some table or maybe holding
And
base.
this one?
This is a backup. So backup is a physical copy. You cannot restore a single table or database. You have to restore the full
Pages.
cluster.
It's alright, of course.
Yeah. So it is during the recovery it will be unavailable, and then actually you just put the files in some
Mhm.
state. What will be the outcome of running restore for PG base backup, which is and pgBackRest actually the same. The outcome would be the set of files on the list. They are not consistent at the moment. So then you start the PostgreSQL and it applies all files.
Okay.
After that, at some moment it says done. I applied all the raw files and I'm ready. Either it's
So extraction procedure is basically I'm calling this diamond and at some point signals that it's finished and then you can start your Postgres instance, right? On the storage.
yeah.
Okay.
Yeah. So yeah, what I wanted to highlight here is that now we have a feature when we can offload the linker node to restore when we want to restore a replica. And at the same time it will be done faster because the files are copied multi-threadedly. And if let's say the linker node is overloaded already, it's heavily using disk or CPU, then you will benefit more. So yeah, this is about backups.
Could we ask some additional questions? What means differential as a backup? What is the difference between incremental and differential?
Good point. So you have two concepts. One is, let's say, you have full backup, then you have incremental backups.
Yes.
You apply them one by one.
Yes.
Let's say we made a full backup on Sunday.
Every week and
Yeah, and then Monday, Tuesday, Wednesday, you have incremental backup. So let's say if the database failed on Friday, you have to apply full backup first, recover from full backup, then incremental, how much? 4
sequence,
weeks.
just sequence. Okay.
Yeah, 4 incremental backups, right?
Okay.
Differential backup is like a cumulative incremental backup. So you would have, if you fail on Friday, you would have to restore full backup and 1 differential backup.
So it basically sums those agreements, right?
Kind of.
Okay, it's kind of incremental. Okay. Next question is related to backup. When you decided to use pgBackRest, did you compare it with Volgy, for example? So I see you have some consequences like built-in backup integrity check procedures. So did you try to compare to other open source tools like Volgy, for example?
Yeah.
And Volgy needs some functionality for you.
Yeah.
Which exactly?
I can show it later
Okay.
after this.
How about this architectural decision was decided? 5 years ago, 7 years ago?
No, just recent one.
Recent.
It was, what we have now, March, maybe half year.
Oh, okay, half year. Okay. In the same case, we just prefer the Volgy because in our benchmark we got much more performance for Volgy. They also support multi-thread and also support S3 menu, but we try to compare with pgBackRest and Volgy, I think 5 years ago. Maybe currently pgBackRest is much more.
We can reach it after this development. I'll open the page where we did comparison of different, it wasn't just Volgy, we compared different solutions and we start from pgBackRest.
I would like to see compare matrix, for example. Okay, and which exactly backup integrity check procedures support pgBackRest? They compare some checksums.
Yeah.
which checksums exactly?
So they file and then they check some of the file. They
Okay.
compare just this. So they do
Do
not.
you mean both files, each wall file, they can calculate checksums for each wall file or calculate checksum for table space files?
I don't remember about the wall files. But they compare checksums for the backup files.
Okay.
For the wall files, we need to check.
Okay, pgBackRest create physical copy of table space and wall files and achieve it in some format like tab or something else.
Yeah, it is archived, but wall files are pushed separately. So it's a separate process. We configure archive command in PostgreSQL, so this is just there is a point pgBackRest where this archive command just pushes wall files. By the way, I didn't mention here, but this is in mind also. So another good thing of pgBackRest is if for some reason, so PostgreSQL would push wall file through pgBackRest to cloud, right?
Yes.
But if for some reason cloud is not available, you have network problems or the performance is not enough, pgBackRest would accumulate them. So it will not interrupt working of PostgreSQL working. And PostgreSQL will be transparent, so it will just push to pgBackRest will accumulate it, and when cloud will be available, it will push again in multi-threaded way. All that it has.
I'm not super knowledgeable about scheme.o backups, but maybe I'm just imagining some stuff. So pgBackRest probably makes a logical application. It listens to the running database.
No.
Okay, so how it actually able to make snapshots of database files for making backups? Like
The
they
same-
able to change it all the time, right?
The same way as PG-based backup. So you have it makes kind of physical copy, not snapshot, just physical copy of what it has. It is inconsistent. To make it consistent, it also keeps both files. That is why we have phase of recover and repair. So we first recover and then we applies wall
I
file.
know how to work Postgres works, but let's say we have running Postgres instance, we have wall file and settle database files, right? And when it's working, sometimes it just gets stuff from wall file, but requires it applies to the database files, from my understanding. Now we have some pgBackup service which tries to listen to this stuff, and then probably doesn't need to stop your C instance, right? So it can take, it needs to copy files, it takes time. So it needs to have some kind of snapshots of current system before copying it, right?
We need it now.
You have a LSN number for wall, and you can physically make hard links and then upload it for table space files. So actually you can filter table space for the applied or not applied LSN, as I remember.
Okay.
So
So Postgres already basically supports to have some machinery which allows you to make backups of running system for physical storage. No?
Yeah.
Okay. And
It is so actually replaying the wall files, making the files consistent is not a part of pgBackRest.
okay, and this particular system doesn't need to have bookmarks on the wall file. I used some other system which basically said, okay, I'm currently replying the wall file from this point and keep hold of it, and I actually had that all time because our wall file exceeded our, it was multiple tens of gigabytes, and it actually exceeded our quota for storage, and it was really surprising because, but it was a logical application. It had a mark basically on wall file saying, okay, I need to keep it before I release it to some other system and grow indefinitely. And it was really strange stuff. But I understand this particular system doesn't use it at all.
It doesn't make any changes to PostgreSQL configuration.
Okay.
So you may have an opposite situation when this system will copy the wall files,
Mhm.
the main backup, while the wall files will be rotated. It depends on how you will configure it.
Wouldn't this make it breaking the backup?
It would not PG. So with pgBackRest we don't have these issues, and we configure it not to have it. But with pg-based backup, that is what I said. We had some inconsistent backups because the database, the clients produced so much changes that both files rotated, and then the backup became inconsistent.
More application. Okay.
Yeah, the last point was here. I highlighted it already has a ready-to-use exporter. If you know the concept of Prometheus, how it works, then you need exporter and then dashboards on top of it. If you want to somehow visualize it, unless you're a fan of writing from fields. So it has everything. You need again open source world.
This is compatible with this RDS. Like, can I use it with RDS databases?
No, you can't, because
I'm not talking about Aurora. I understand it's very different, but RDS also.
RDS doesn't allow you to connect to the system level. All you have is just a database connection. So you can use logical backup done with using pgdump, but you cannot have physical backups.
I see.
You can use there again Amazon's solutions. Like I like to have backup, and then you say if it should be stored in the same region, other region, and so on. How many backups? How long you want to keep it? But not on your own. You can't do it on your own. Security, another layer. So with security, we have encryption on all layers. As it was on Wednesday, who was participating, it was said that TLS is like default now, should be default. And then actually it was shown in the presentation that they did some research and we showed that about half of the database doesn't do TLS. So it should be default, but it is not. We use TLS for connections, even between the database nodes. We try to follow zero trust model that is enforced by our security team. We're not there yet, but we're slowly coming there. Then, if we complete with encryption and so on, we don't allow using MD5 for storing the password. It should be in the documentation. I would recommend it for everyone. You don't keep in PGP MD5. It's outdated, and from PostgreSQL, I don't remember which, 17 probably, it is degraded, so we don't support it. Then, each database, this is agreement with developers, each database is a separate instance, and all clients, a client from one service can connect only to each database. No access to other databases. It gives us some flexibility. It, of course, restricts adds some limitations on the client side, but it gives us a lot of flexibility because we can scale. I will tell a few words about the scale later.
So no usual approach when we're using one kind of both to master and replica and user for reads, but master for writes.
This is fine until as far as you're connecting to the same database.
Okay.
So let's say who is the account server? Account server should connect only to account server database, not to
and for myself, you're using microservice classes or.
It is microservice approach.
Your approach is basically no microservice should talk to multiple databases, and you should use other data connections for.
Not connections. So if one service, one application needs some data from other service, it should interact on their level, on the service level.
This was nice.
Role-based access control. This is done, well, applications. This is again another agreement with developers is that we provide you the database. So again, referring back to the developers self-service. Developers, what they do is just during the deployment they ask, they ask, I need a database, please give me. Then what they will have is and also with this username, what they will get is an outcome, is a password, and this is actually knowledge that there is a database with this thing. This is what about servers. Now, game developers, also testers and QA and support team, they sometimes need access to the database. This is done on a personal approach. So each and every one, physical person, me for example, I would have to request, like, give me please access. We will create a database user in database with some password. We don't know what to do with the password, it will send separately. With permissions to access the specific database only. Moreover, we now, because there were cases when some users copied the data and then just too much data. Let's say if the user would have access to account server, then they would have access to accounts information, right? Emails, names, and so on, phones. So now we build another approach. We have another abstraction layer based on views. Views would hide the sensitive data. And these accounts, not the service accounts, but the user accounts in the database would have access only to views, not to the tables. With that, we also hide the sensitive data from the view.
Before we didn't dive to row level security.
Row level, at least we know there is such feature, just there was no such request.
Okay. It's just basically Postgres is kind of orthogonal. You make row level security and you make row level security, and they don't super play well, I would say. For instance, Huawei is not scalable. Reason it was interesting, but I didn't like the experience at all. It was weird.
For me, I would say that role-based security makes sense if you have the same system accessed by different departments, let's say.
Yeah.
In our case, it's still it's service-based. So you have service disconnects, yes, it's on database.
Sometimes there is approach like it's older approach. You can also make your application which goes to the database, but application depending on which user accesses this application, switching their role, which is connected to the database. Which is problematic when you have thousands of users, Postgres doesn't take so many, and usually nobody does it. Basically, you have one kind of role for connection from the application to the specific application to the database. We probably do the same.
I can say actually that this approach that we implemented with PostgreSQL is a pain. Because it is probably you wouldn't face it until you do it, but in PostgreSQL views and tables are linked in a Linux terms with a hard link, just to give some similarity. While, for example, in MySQL, which also have MySQL MariaDB, they are making a soft link. We don't have the problems with it, but we have a problem with PostgreSQL. What I mean? Let's say you created a view over a table. View is, as I described, view is something auxiliary, not the main thing that the developer will expect when he asks for a database and then creates a table there, right? It is something we bring for safety. Then when they want, let's say, to change a type of column or to drop an existing column, it will fail. The operation will fail because there is a view.
Or cascade will build because of cascade.
If you apply cascade, then he will not access. He will not have read access. So we implemented a lot of things like workarounds. We had to ask them, like, before you do a rollout, we need a handler where we can inject our logic. Then at the end also we need to inject our logic for the drop views and create views. But it's complicating things. With, let's say, with kind of soft link approach, which is in MariaDB, they don't have that. We can rename it in a column in a view, in a table. The view will fail, but at least the operation to rename the column will not fail. There are pros and
So
cons.
basically, you're keeping dependencies of views on tables separately and intercepting somehow every alter table request and creating views which are dependent.
Not that complicated. So before the developers, before the component would say that I'm planning to do migration, some migration from PGP, they would call our playbook in console playbook if it's familiar. So some steps that we need to run. What we do is we just drop all the views.
Okay.
At the end, when they completed the migration, they say, we're done, then we're just recreating all the views.
But dropping views could be done by cascade.
Yes, but again, that means that developers, when they write the migration, they should keep in mind that there are views which we didn't create, but we have to keep.
You know what they did? It's probably not for your scale or but what they did in based startup, which is very small, but still we write a lot of logic just in very quick scale because they don't have backend actually. They use PostgreSQL for authentication or security. So basically you have the database and this is it. And you have to code business logic in the SQL and stuff like that. So one of the problems, because Postgres has a concept of cascades, sometimes you drop a function, it drops a lot of stuff, sometimes it's not. It depends on if you use quotes like strings or you just use identifiers. So cascades is not reliable. So basically after each migration, on the CI server, I run them on the copy of database, or not copy, like build copy. And if then I dump schema again, and if it's different from what from developer push to the CI will fail. So let's say, okay, you think you dropped just this, but you actually dropped that, and that. Please review. So basically, it wasn't forcing you anything. It was already stored around Postgres cascades, but you will see all the changes. Not only what you think you change, everything.
Yeah, it makes sense, but again, we solve our problem by complicating more with developers. We don't want it. Monitoring, we're already like out of time, I suppose. And we're just here at monitoring.
We have time.
We have?
Yeah.
Okay, fine. Then monitoring is our killer feature. We use Prometheus for metrics, pgwatch 2 for PostgreSQL metrics, not important for system metrics. If again there are many exporters for PostgreSQL, we choose pgwatch 2. And Grafana for visualization. But what we did is actually here is a concept where we use open source and we change it. So pgwatch 2 initially and out of the box we didn't like their concept and how it worked. We reworked it and now we just have some customization. It helps sometimes, it just makes it more complicated to update it because we need to see what has changed. But it makes it more close to our system. We even push back some changes. I myself created some pull requests to pgwatch 2, saying like, guys, I think it makes sense, it will work better, this is more conceptual and so on. So yeah, by the way, also push back and we also interact with all the stuff we use. And on monitoring, I will pay more attention, some more details later. Just with logs, we also use Elasticsearch and that's it. Again, everything is transparent except parameters. PostgreSQL is configured so in a way that we don't have parameters logged. It is, again, sometimes it's a pain, but sometimes developers push some sensitive data parameters, emails again, and we don't want it to be published in internal systems. So, pgwatch 2 and its dashboards. You see, this is the dashboard for monitoring PostgreSQL. The initial idea was, we need, again, we're a small team, and we have hundreds of developers around. We want to make it so that for developers, database will become as transparent as possible. Ideally, they would operate it and find their bottlenecks themselves without enriching us. And actually, we achieved this result. So this is the main dashboard of PostgreSQL, where you see there are many rows, existing database storage insights, tuples, transactions, logs, scheduled digits, so the rest are not so important. The first system is you often need to compare like, what is on the system level, CPU, RAM, disk utilization, and then to match it with the database. That's why we moved it here. You can open and see, to check. I know I don't have system screenshot. And you can see how many panels inside, right? 14 panels for system, 14 for databases, 3 for database storage, because we don't have many of there. We will have there just how much WAV files consume, log files consume, data files consume, each database size, and that's it, I suppose. Tuples, and also show details. And some main information, including load. You can see that there is a load, we show also. Some developers, sometimes initially they were concerned about it.
What's block?
Just
Load is a problem in PostgreSQL where you have unused space
So we need the block, right?
and you maybe need a backup.
Okay.
With 3%, almost 4% blowout, we don't need backup. I remember we had an issue many years ago, we had a discussion with numbers. We have a lot, some percents, we need to clean it up. And I had to explain to him, okay, we'll do it now. And just in 1 hour, you have a lot again. Are we going to clean up again and again and again? We don't need it, right? So 3% is considered fine, even 20% I would say is still very fine. Again, it depends on the system. So queries per second, production per second, you can see there connection utilization with how many, 23% is fine. Also, DB uptime, instance row, you asked before, right? What is do not, here we have leader, then we will have replica, it's replica not. Well, that's it. I think we can skip to the next. Here, when developer, let's say developer who doesn't have much knowledge in database, but he knows how to work with the dashboards, here we would see the databases. I'll tell it later, but we have a concept of shared database instances and dedicated. Shared is when you have a database instance and you have many databases in it. And here you will see the situation in this case, just I do it again because there are real database things. But you have all the databases inside the cluster. You can see here how much time database spends on the top row is how much database spends on processing the queries from each database. Then you can see it's like database time per minute. And you can see here, for example, that the spikes are about 1.7 minutes, which means it's about 2 cores. Database utilizes 2 cores. It's not loaded database. I don't know why, but we'll be outside of
Then minutes, what was minute here? Minute per hour?
minute per minute.
Minute per minute.
Yes, so like how much time database spends per minute on a processing
So,
queries.
I mean, 1.7 minute, okay, minute per minute is interesting metric for me. I would say it's not obvious that it's actually a right.
we're trying to measure utilization of your whole system.
Yeah, I understand, but still, minute per minute would be not like it should have a measure. It just should be a ratio, right? And we have
If you have multiple core system, it's a similar load average, but it's much more reproducible because this is proxy metrics is not only CPU, it's also affected by the I/O, for example.
Yeah, I understand. You just again, I am surprised to see it's working here with just one cell, which is understandable. Okay, you mean per minute, which is not displayed everywhere, is weird.
What is difference? Like, it depends on what is more.
Like what if it's how can I see that it's not 1.7 minute per hour or per second? Where is it in this chart?
It's just because I know. And now everyone in company knows. If you need it, you can time it. You can just write any time, comma per minute, right? But then tomorrow I will change the expression from here, and it will be per second. Actually, what I tried to do, but then it looks weird. So here, what would we do first? We see that there is one component that consumes a lot of time. There is just 1, 2 cores used, so it's not, we wouldn't spend a lot of time on researching, but we have 20 minutes also systems. Then we would drop to a query tables. We have it also. But we'll issue. Then we have cache iteration, I suppose everyone knows what it is, queries per second, session details, and many more. There were 14, right? So this is just 4. But DB time is the most important. Then from DB time, we can, no, it's tuples. Tuples details, we can see which service, details for each service. How many inserts of data lists are there, and how many return and fetch tuples per second. By the way, here it's per second. This is not that node, it's a
Common profile for what?
kind of shared with the whole company. And again, it reduces our headache and our problems. We can focus on our more strategic things.
And I would say it's useful when you're debugging your application of your database because basically from the database perspective, it inserts and updates and then it deletes basically the same stuff. If you can support IO or stuff like this, right? But for application, you can say, okay, I actually have more inserts, maybe this particular service is anything more.
Generally, you don't care about how many inserts are data you have until you have problems.
I had situation when I really freaking didn't care.
Maybe.
Okay.
Maybe there are some such cases, but when it will be helpful is, let's say, yesterday we had some problem. Customers were complaining on their service degradation. Response time, I don't know, website, Meetup. Here is when we use it. We need to understand what happened.
So this is what I'm saying, it's correlation from your application to workload to database. But yeah, I actually had a situation when my database was slow. And I know what application did, but I need to understand why the database was slow. And for me, this chart wouldn't be making much sense, but actually tuples pushed around, which is basically some of this older charts. What makes sense because I was actually pushing my quota on the database, not on IO. So this was our guess still, but we actually had situation when I pushed so much data that my bottleneck was block storage and the database instance.
But you would also, again, visually you will see this.
Like I know, I need to see basically some of those charts.
Yeah. And from each of them you can drop down even to table details. So let's say we have this spike, but it's just that big spike, right? We can drop down to tables overview to see actually what tables was affected the most.
And probably indexes as well, right? Update of indexes to tuple as well, right? I'm not sure.
No. So in tables, tuples, indexes, we would see again if there is an index dashboard separate one, but you wouldn't see there like how many tuples in index for the data.
Okay.
I don't think it's useful. These two concepts also return the fish. We first introduced it, then we had to explain to developers what it is and how to use it. And you can see that there was some spike, right? 1 million row tuples returned and about 200,000 fish. So this is the concept. And the idea is when you run a query, first database has to read tuples from tables.
And this will be fetched, right?
It will be returned. It's
so
like a return from data files.
Okay.
And fetch is how much data, how much tuples were returned to the client.
it should be vice versa.
It is, for me,
I understand.
for me, I feel the same because naturally I would like to replace them, but that is how PostgreSQL called it. So we decided to stick to the same names, not to create a mess here. So what you do usually, what developers would do, or we actually would do, is to compare this to find a ratio. If the number of return tuples is much more than fetched, then probably the queries are not effective. That is the idea.
Not enough indexes or stuff. And I see that there are like very different scales here.
Yeah, that's what I was saying. Here we have a spike 1 million, while the return was just about 250K.
Kind of gauge. Okay.
Which means we would come from the developers asking like what was there. But before that, we can even check what table was affected.
Are you able to do like separated for roles, like from standpoint of the application developer, right? It's completely different stuff, like what you see when you just usually browse your application and what you have when you're running reports of some sorts. And the reports will have completely different picture here, like completely different. It's absolutely normal to run a long query which makes full table scan and stuff. For observability, it will be probably nice to make a specific role for reporting connections. In this case, you would see different pictures separated, right? It will be possible. Can you make this charts we have here, but split your role or connection?
We can, but we'll have to change the expressions. So there is a row, there is a user data, we don't use it.
Okay.
It is possible.
And this is all this interface is again this is parameters, right? Or
This is Grafana.
Grafana. So and your queries you're saying is to Grafana backend, right? So basically you can make
No,
charts.
Grafana is UI.
Yeah.
Grafana is UI. You have Prometheus as the storage. So Grafana is just visualization.
Yeah,
You
yeah,
write
okay.
it from QL queries.
I mean, what I'm saying, Prometheus have in storage granular data, enough granular data, so basically this is aggregated information.
Yes, it's always aggregated information because Prometheus have a scraping per mile.
Yeah,
Usually it's
I'm
15 seconds.
not saying about times frames, I'm saying about how granular your stored data, because
One
most,
every minute.
I'm not saying again, not about data, like if you have your data, for example, read tuples per row, you can make charts, of course, make aggregation of like give all the read tuples, right? But if you need later split per row and you aggregated it beforehand, you cannot unsplit your data based on groups. You know? So I'm asking
Okay, you ask about drill down navigation. You
Yeah.
need to look to the spike and try to click and drill down.
Yeah. This is basically requires
No, this is not for pgWatch. It's restriction for. It's just an overview of system. You cannot debug your application from this perspective. You can overview your database as a service. It's another kind of tool should be applied to more granular. For example, you need something like code which allow but your application is PPF and allow store more granularity pgstat statements information. So I think you have dashboard related to pgstat statements, yes. So
Yeah. So probably I'll answer your question later.
yeah.
So proof.
Sorry.
So as I said before, right, the DB time is the top metric, top panel that would be interesting for the developers and for us also. From it, you can drill down to top queries per calls, query information. So here you will see what the queries again. Queries are here. That's fine. The database I hidden them. So you will see what are the rate of queries, how many queries I have executed from applications, what is the time spent by database in each query. Here, it's like before we had DB time is fine. Okay, we see that this service produces big load on the system. It was then. Someone had to connect to a database to do some research or to analyze the logs with pgBackRest or whatever. With this, we don't need it. It is built on top of pg statements. And actually, yeah, we have everything that is needed to find out the root cause. Up to the query, you see, there was some spike, database spent 600 milliseconds on it this time, but we don't see it anymore, so probably just one time spike. You can create a button developers to find out what it was, and so on. Or we have some constant load within this query, which is, I don't know which one, but it is like constantly executed every, what is it, 5 minutes? 10 minutes? So this kind of analysis we can do. We can even drill down deeper and say, I don't have screenshots for that, but you can click on any audit query and get query details. You will have full query text. You will have information like when it was executed, how long the database spent, and each and every moment. You know, did it hit a buffer, or it had to read data from cache on it? Was it cache hit or cache miss, and so on. You have all the details, and it is really useful. We use it quite often.
I can surprise that I don't see columns.
Hmm?
I don't see columns anywhere. I see static stats from the query, but let's say particular query is not big, but it count it's fired like
You can do that
times per second.
Here it is.
So
Where
basically
it
I need
is.
to cover it, right?
Hmm?
I need to basically use mouse to see. This is count, right? This is my own seconds and this counts. Okay.
Yeah, you have two
My
main.
counts, I see.
You have two main problems, right? One query may be slow, and you will see it here. Another one maybe it's frequent, but it's fast, so you wouldn't see it here. For that, you have it. Actually, there are other payments also, like query usage of memory, disk, and so on. Just again, it's too much information. Another thing that we use is we have timescale for time series data. It's an extension for PostgreSQL, but it's a huge extension. It's not like this small extension like that now. PG start statements and so on. It is really changing the concept of database. And even so, when we rolled it out, we had a concept of we had all the monitoring in place. We had monitoring for tables, indexes, and so on. Then we rolled out timescale-DB, and we found out that it doesn't work for timescale-DB because they bring their own concept. They have hyper tables, chunks, which chunk is actually a table in our understanding, but again, it is now chunks, called chunks, jobs, background jobs. And we started building our own dashboards. So I'm thinking actually to share this pgWatch because it's unique. I wasn't able to find it over the internet. No dashboards, no exporters. But now again, TypeScript for us is also visible, and we are keeping our idea, which is that everything should be transparent for developers. They want the timescale DB for time series data, they have it, but it wasn't clear what is there inside. Now we have. And we found, by the way, a lot of problems when we rolled it out, which now will resolve. Like some chunks were compressed, jobs were taking a long time, and so on. Scaling. Guys, if you don't mind, I will just run briefly through the other topic because it's already like a lot of time. Took a lot of time. So scaling. We scale initially vertically, everyone does it. But then we not to have super computers. We just agree that each server should have not more than 2 terabytes of disk space, and just we have to live with it somehow. Then we are just implementing some solutions. Developers have to implement the sharding strategies. Or just dedicate the cluster is enough. Again, I said before, we have ideas of dedicated clusters, database clusters, and shared clusters. Here, databases, services who has databases less than 50 GB, they can use shared cluster. If there are more than 50 GB, we're saying, guys, you have to go to dedicated cluster. It's kind of a balance. I know that, for example, in microservices, you have to have dedicated instance for each service. But we decided to go in some balance with it, not to have, we have databases of 100 MB, 10 MB, and so on, like why would I have different separate instances for that? Rescalability, it was already the question, right? So we use replicas not only for high availability, but we use it also for scalability. The clients, the same that we use for scalability. And here again, console helps us, Patroni helps us, because Patroni not only synchronizes the information on which hostname, which IP address should be assigned to a link or not, but also replicas. So again, for developers, it's also transparent. They're just play with the host.
To the support instance. And support instances you have only one size, 1 2 terabytes of disk size and some fixed multitude.
Is it vertical scaling or?
You can work vertical scaling. Like for me, it's always interesting how do you scale the database in CPU and storage without moving quick flat. And
It's easy. We have virtualizations. So no one shares 2 terabytes at once, and no one gives, I don't know, 50 cores to the database service. We start with small values. Then when the service grow up,
your virtualization allows you to move basically a chunk of slice of
Acronis is mine vendor for virtualization. For example, they developed some MacOS virtualization. So I think you have a virtualization platform like something like
virtuoso.
So Virtuoso allows you to move random instance from physical instance to other physical instance without trying to fly.
On the fly?
No, we don't need to move it from one instance to another.
One you had 2 slices and one is growing enough that it's too easy for.
You have one physical server, 2 virtual machines, and 1 virtual machine should grow.
Yeah.
And you don't have enough resources on this.
We have 3 nodes, right?
Okay.
So while one node is handling the loss, we
You
can
can
do whatever we want with the
So
second.
you do dance with the switching to primary replica with other.
Yeah,
Patroni on old.
and it works perfectly, even on a heavy load systems.
Okay.
But, so we're finalizing. Yeah, great. So to what else to say here? Without having a vendor at the backend with their SLAs, we have to provide somehow SLAs on our own. How we'll do it, how we'll achieve it is we grow up our internal expertise so that everyone in the DB team, of course, they know it, but also we share knowledge. This not strategy. We share knowledge with developers, with the operations team, so that the whole company would increase their knowledge in databases and technologies and how to work with them. Automate as much as possible. Playbooks for everything, or almost everything. We use, I didn't say before, we use Ansible for rolling out changes. Well, yeah, probably that's the main effects. Of course, if we introduce something new, then we have calls, reviews, explanations, like for backups, pgBackRest. Then we have a call with developers, with operations team, explaining them what it is, how to operate, what to do, the same with Patroni. So all the major things are done in that way, introduced in that way. Yeah, here's a quick summary of key technologies we use. Not all of them are here. We use more. Just this is some came out behind.
Some keywords for research.
Yeah. There is a picture that I didn't mention before. Yeah, so to sum up, using open source technologies, we can build.
How many tenants? 50 terabytes. And how many tenants? How many microservices? 100. How many data per microservice? Average.
This is another concept. We have, it was, as it was said before, we have more than 50 data centers. Each data center, it's also kind of part of a sharing strategy. So each data center is actually a copy of each other, not with data, but with the topology. Then
so it's
150
100
terabyte
per
is
data
some-
center or
no.
the whole system?
total size. The biggest data center would be again terabytes, some terabytes.
Okay, so look like usual your database size is something like 10 terabytes per PostgreSQL instance.
No, less. As I
Less.
said, we agreed that we
1
want to grow
terabytes maximum. Or
2 terabytes.
2 terabytes per database.
So this is basically, if you like say over, just I think sharding your application usually not a small task, and it takes quite some time, especially if you don't think about it out there. And you say, okay, you know what, you somehow grow your database to 200 megabytes. Well, why you didn't make sharding beforehand, right? So no special instances, nothing else, right?
You're right, but few points here. First, not many services require 2 terabytes, grow up to 2 terabytes. We have more than 50 services that have databases, and only 2 of them are websites. This first. So it's not like it should be applied to each and every service. The second is, we know the services and we work with them in advance. Even when they were already like less than 1 terabyte, we ask them, guys, you're going up, and in let's say 1 year you will hit 2 terabyte. Let's think about sharing strategies, and it was said that we tried CytusDB. We thought it would be a good fit to solve this problem, but it didn't. CytusDB has its own drawbacks, so we just didn't solve our case. It didn't match our case.
I just had an experience working on a pretty small startup which had about 150 gigabytes of data total. And it's not global, right? And I thought, okay, it's small, we shouldn't care about local stuff. And I actually had a outage because, as I said, we set up a local application from on-site contractor. He put it in mark on our log, and our log increased our storage quota to 3 terabytes, not 2 terabytes, right? So because our data was small, but because the churning data wall was dead, and he just held it like for I think 4 days, and it was enough to move our really small, simple database past 3 terabytes of storage total. And in your case, it would be already like a disaster problem.
In our case, we wouldn't hit that because we have alerts, and you should have alerts.
Yeah.
So keeping something on a wall file means you open the transaction. If you open the transaction, we would have alert like something is wrong. For after 1 hour, if we have open a transaction for more than 1 hour, we have alert. It's not disaster, of course, but it will be visible.
In our case, it's what was expected. But yeah.
And you can set something else. I don't know, 4 days.
You
That's
have
the
connection in the linear, or not in the linear, in the waiting mode. If you have long transaction, you have connection in the specific mode.
By the way, it wasn't a transaction, it was a logical replica, and I think it's not handled as a transaction, so it will be easy was a long transaction, it's something else. I'm not sure what the machinery here, but it basically says, okay, there are replica, I don't know, I call it bookmarks, but it's not. Basically it says, okay,
It's probably something in the slots.
yeah, replica slot, yeah. So
Yeah.
it was forgotten replica slot, and it was held here for 3 days. It was enough to have a notation something. Because
So
basically,
when we wake up on Sundays, you need to know.
yeah, by the way, it was basically because RDS had the upper limit which we set ourselves, and we thought, okay, it's 150 gigabytes. We don't need more than 4 terabytes, right? And it was just enough for this bookmark. But in RDS case, it would just scale up silent, like invisible for us, right?
We're also using logical applications.
Mm-hmm.
But we're using with attention and care because there are possible some consequences like this one.
Mm-hmm.
So we have alerts even on that, and we track all the applications.
Okay.
So you always should keep in mind that databases is the most alerting system in our
But in your case, you rent physical instances, storage is attached to the instance itself, no trying to make block storage separate from CPU, nothing like this, right? You just basically running virtualization on normal machines, no
On
stuff.
bare metal. You have bare metal infrastructure or you use managed cloud providers?
No, we have our own.
Okay, that's your bare metal infrastructure.
We there is support for deployment in the cloud.
Mhm.
Just we didn't yet roll out in production. So it's also possible. No problem with it. We don't rely on what is there under the machine on our performance.
Which component do you use for the connection pooling? pgBouncer or something else?
We have pgBackRest, but we don't use it mostly only for services that opens and closes connections very often. We ask them to switch to pgBackRest. For the other services, we're fine with just connecting like this.
Basically, pgBouncer for you is
Okay,
application.
pgBouncer it's option, it's not the requirement.
I've never used console, but I understand that it's story service. You said something like, okay, your application go to console to see which IP is set to this particular.
It is using the uses service discovery.
Yeah, so do you understand this right? This console basically works as DNS. So you were using DNS, not using special
Of
console.
course, not digging like dig the hostname and getting
Okay.
parsing and so on.
And it's fast enough and no cache and you are no publisher, right? Like
Yeah.
DNS would be cached, right? So it's some
There is some
variation.
small cache,
Okay.
some kind of milliseconds or
So
because we had longer cache, but it caused problems when we had switchover of a leader. Then application would have few seconds of errors because it would try to connect to the old leader, which is now replica.
Mhm.
And
So again, application you need to have this logic to see, okay, your connection is dropped down, you need to refresh your address for.
it would be interrupted just naturally.
Or
If you have switch over database or leader, then the old leader would be restarted.
no trying to push update stuff like, okay, in the case you start trying to scale vertically, you need to switch from main replica to the from the main to the replica, right? And you basically just drop connections and we
Yeah,
have to
which
see
is
how
right.
to find out.
Do you use some resilience framework on the client side? I mean, your development team understand your PostgreSQL put down in any time and say retry connection, retry transaction.
This is agreed initially, so
Do you have some common framework on the whole company, or each team solve resilience and high availability from client side separately?
as far as I know, each team resolved it on their own. But that's a good idea. To implement it in your own.
What manages that your replicas and masters not residing in the same physical machine or the same, I don't know, rack, or maybe do you put your replicas in separate data server,
Physical server.
Data centers.
data center?
No, we don't have cross data center applications.
So in one data center, but we still probably try to
So different servers.
different servers. So I understand that this thing you for managing infrastructure has affinity of sorts, so it tries to make sure that it's not easy for
So doesn't mix or slave and master nodes on the
Yeah,
same
it wasn't the
physical
same
hardware.
because I've heard for storage, so like someone set up I know Cassandra cluster and put stuff on the same machine still, and they say okay, a furry replica is actually having a write, it's all safe and it's all goes down, and it's not like a data center size of all pages, just one single record is a failure.
Yeah, many years ago we had similar solution, but not really like it, just two nodes were the same. And we have host, and after that we put it back there. Thank you.